In this exam, we're given data on higher education institutions in the United States. There's this IPEDS data. It has institution name, unit ID, a 6-digit unique ID, but then ID prefix, state, city, region, year, admission, number of admitted students, number of applications, and other things. In addition, we also have some data on earnings by graduates, all right, with some other fields. Okay, let's get started. Now, what is the unit of observation of the IPEDS data? So let's connect to that data. I downloaded the data in my downloads folder. So let's connect to it. And we see there's the year, there's the institution name, unit ID, and then some 6 digits, state, city, enroll, tuition fees. These look all like the right data types. Okay, and we're supposed to find the unit of observation. So let's take a look at how many observations we have. 13,342. How many institutions is that? Well, it's 2,000 distinct institution names. It's quite possible that some institutions have the same name. So let's see what happens if I add unit ID. Well, that increases the number of rows, but that's still not the unit of observation because each institution is there multiple times, some of them 8 years. I wonder if a year can help us here. Let's make year discrete so that we could see the distinct years. And indeed, now we have 13,342 rows. The unit of observation is an institution as identified by unit ID and year. Okay, next question. How many institutions in 2021 share the same name with at least one other institution, even though they are different institutions as identified by unit ID? So let's do that. Do that in the next sheet. Let's take a look. First, we need to limit ourselves just to year 2021. And then let's take a look at institution names and how many times an institution name appears in 2021 in the data set. And most of them are there just once. Let's put a filter on count. Let's see if we could filter it from 2 to 3, because we could see that there are some institutions that have some institution names that appear there in 2021 3 times. Okay, and here they are. That's 10 distinct names. How many institutions is that total? Let's add a column total. It's 23 institutions. So 23 institutions, including 3 union colleges, have the same name, but are distinct. They have a different unit ID. Okay, are there any institutions that changed their name during this 8-year period from 2014 to 2021? How can we find that out? So now we're not going to limit ourselves to year 2021. Instead, we're going to take a look at, let's look at the institution name, and let's look at unit ID. And let's reverse the order to see if there are some unit IDs that are associated with different names. And we can clearly see there's a Birmingham Southern College. Some years it appears with a hyphen, some years it appears without a hyphen. Let's see, here's Williams Baptist College. And then same unit ID, William Baptist University. Let's actually keep only William Baptist College and William Baptist University. Let's keep only this unit ID. Let's actually now add year, and let's make it discrete. And we can see that the William Baptist College changed its name in 2018 to Williams Baptist University. They kept their ID. It's the same place, but it has a different institution name. Fantastic. Next question. Create a time plot of average tuition and fees by sector. Okay. So we need a time plot. So we're going to put year, keep it continuous. Tuition and fees, we put that on rows. By sector, so we're going to put sector on color. And we said average, so we average across institution within each year. We see that in 2021, tuition and fees on average for private not-for-profits reached around 34,000. For publics, it's a lot less. For-profits are in the middle. However, this does not take into account financial aid, and therefore in the second part of the question, I ask you to plot average net price. So that's a cost faced by students with financial aid. And of course, those prices are much lower, and now private for-profits are much less expensive. Well, somewhat less expensive than for-profit, still more expensive than publics. But certainly the ranking has changed. I asked to add a sector label to this. Actually, let's add sector labels to all marks. So I'm going to switch here to all marks, sector label. Let's make it prettier so that we can actually see the labels. Let's change the start of the axis. Let's make it start in 2014, and let's extend it to maybe 2024. Yeah, 2024 gives us a lot of space to actually see which line is which with the label. Okay, next question. Create a row level measure of admit rate. So number of admitted students divided by the number of applications. Create a vertical bar chart showing the admit rate. Then do the same thing for aggregate admit rate. Do this all for 2021. Okay, so we're back here. Let's create admit rate. So admit rate will be admissions, number of admitted students divided by applications. And we can put that up in rows, make it the average. So we're averaging across institutions, and we want to slice it by sector. And we can clearly see that the average admit rate is lowest for the private, not-for-profit schools. About 65% students get admitted on average when we average across institutions. However, there are some institutions that are big and some institutions that are small. Well, some institutions that receive lots of applications, and so let's see if we could weigh those big and small institutions differently, because this is unweighted average, and we can achieve that by creating an aggregate measure of admit rate aggregate, and it will be the sum of admitted students divided by the sum of applications. We'll say okay to that. We're gonna put it in the same chart. So now we have aggregate admit rate. And we could see that certainly for the private, not-for-profits, the aggregate admit rate is much lower. Why could this be? Well, it must mean that institutions that receive lots of applications, means they actually carry bigger weight in this aggregate measure of admit rate, are more selective. That actually makes sense. I think Harvard and Yale, those institutions receive lots and lots of applications, and then they admit very few students. And then you have some smaller institutions that have a higher admit rate. And those smaller institutions carry as much weight in this bar as institutions that receive tens of thousands of applications. And so when we do the aggregate, the weighted average, the admit rate is lower. Next, we are asked to create a highlight table showing annual growth rate of first-year enrollment. So let's do that. Let's put year in columns, and let's make it discrete so that we can create a table rather than a chart. We are supposed to break it down by region, and we're supposed to sort the region by total first-year enrollment. So it's going to be this way. So Southeast is the biggest enrollment. Rocky Mountains has the lowest. Let's actually put the sum of enrollment, and we want to see the percent changes from year over year by region. So let's add a table calculation. We're going to take a percent difference from across the table. There we go. Let's make the mark a square. And let's put the change in enrollment, not net price, change in enrollment on color. So of course we have to apply the table calculation to the pill that we mapped to color. So add table calculation again, gonna do percent difference from table across, and that makes sense. I really like to use red and green diverging color scheme, anchoring it at 0 so that we have the increases in enrollment in green and decreases in red. You can clearly see 2020 stands out where lots of students delayed their enrollment in colleges. All right, fantastic. Next is create a vertical bar chart showing prices. Okay, so we're going to be comparing prices across sectors and regions. And we're going to limit our chart to combinations that have at least 30 institutions, to sector and region combinations that have at least 30 institutions. Okay, let's do that. So we need net price, vertical bar chart, and we want average net price. Okay, around 20,000. We want to slice that by both region and sector. And we want the sectors within each region to be next to each other. Okay, so that makes sense. But this is a pretty bulky table with lots of bars. And so we want to limit, we want to show only bars that represent at least 30 institutions. Okay, so if Southwest has very few for-profit schools, we don't want to show that bar. We want to only show categories that have lots of institutions that are meaningful. A meaningful number of institutions. In 2021, we were told. So let's put in a filter for 2021. And But now let's put in a filter. So we need to put a summary level filter where we're going to be filtering on count, and we want at least 30 institutions to be represented by each mark. So I'm going to say okay to that. And that makes this table a lot smaller, a lot more manageable. You can nicely see only categories that represent meaningful number of institutions, which is good. And you can clearly also see that private schools are more expensive than public schools. Let's put color on a sector label. And in the second part of the question, we're supposed to put a label on the average price of the public institutions and see how much less expensive those institutions are relative to private institutions. So we can add a label of net price, average net price. We can clearly see in Far West, public schools, private schools on average cost 29,000, and publics cost only 12,000. How much lower is that? Well, we can calculate a table calculation where we're going to do percent difference from table across. We actually don't want the table across the whole way, because we're not interested in how much more Great Lakes private schools are relative to Far West public schools. We're only interested within each region, which means we're interested in a table calculation across each pane. And there we go. That's a pretty nice chart. I would probably format it as well to reduce the number of decimal places like that. And we see the biggest gap between private and public institution in terms of their cost, net cost, is in Far West, which includes California. So the public schools in California are pretty affordable relative to the private schools. Okay, excellent. Next, we are supposed to join the IPEDS data with the earnings data. So let's do that. I'm going to go back to our data source, and we'll need to think about this joining. All right, so I'm going to add the connection to the earnings data. And it's actually offering us to join right away. We've got IPEDS and earnings. It's offering us to join the data on institution name because it detects institution name field in the IPEDS data and in the earnings data. However, we know that if we do that, we're going to have a problem because institutions or institution name is not a unique identifier. We have 3 different union colleges in the IPEDS data, and presumably there's 3 different union colleges in the earnings data. And so that alone would generate 9 different observations because it would match each union college in the IPEDS data to each union college in the earnings data. So we don't want this. We want to join the data on a unique identifier. The unique identifier of colleges is a unit ID in the IPEDS data, and it is unit ID in the earnings data. Now, it doesn't like that. Why not? Because if we look at the description, we could see that this IPEDS data for some reason has an ID prefix in there, whereas unit ID here, that doesn't have a prefix, just 6 digits, and we can see that here that the unit ID in the IPEDS data is oh, unit ID in the iPads data. Where are we? There, it's a ABC. It's a number. Sorry, it's a character. But if I scroll down here and I hit the yellow, which is the earnings data, I see that the unit ID here is a number because it doesn't have an ID prefix. So we're going to have to do some work. In fact, we'll have to do a join calculation where first we need to remove the ID prefix, which means we only want the 6 rightmost characters from the unit ID in the iPad's data. And then we need to change the data type so that it is an integer. So this calculation is going to turn the unit ID with the ID prefix into just the 6-digit number without the prefix, and it's going to make it into an integer, into a number. And that can be matched with a number in the earnings data. So let's see if that works. I'm going to say OK to that. And we see that now we have some matches. Here is Alabama A&M University. And there's the original unit ID and all the iPads data. And here is the earnings data. And here's the 6-digit unit ID. It treats it as a number. So that's 10,00654, which is the same as the 6 digits in this unit ID. And the institution name in the earnings data also matches. And it's not a unique identifier, but certainly for most of the colleges, it should be the same. So the unit ID in the earnings data represents the same thing as the unit ID in the iPad's data. We're also told to keep all of the iPad's data so that all the work that we did earlier does not change, because in case there are any colleges in the iPads data that are not in the earnings data, if we did an inner join, the tables and charts that we made would of course change because it would eliminate colleges that are not in the earnings data. But we want to keep all of the iPads colleges in there, and where we can, we add information about the earnings of their graduates. Okay, fantastic. So we can actually check to see how many observations we have now. We still have 13,342 observations. All right, but now we can see what is the relationship between net price and earnings. And earnings are over here. And we want to show this relationship using 2014 data, because the earnings data comes from people who were enrolled in 2008, 2009. So 2014 is really the closest. This, of course, gives us just one data point because we want to break it up and show it at the unit ID detail, at the detail of an individual college. And so because we limit this to 1 year, each data point here represents just one row of observation. There's no aggregation. So if I change this to sum or average, it's not going to make any difference. Just you can see nothing changes. Let's make this a little more informative. We can already see that there's a positive trend. More expensive schools produce graduates that earn a little bit more than less expensive schools. We can certainly put the sector on color, and we can say the size of the school using enrollment. We can put that on size. Let's make that a little bigger. And we can use up all of the space here. We can add a trend line. And let's make the trend line common to all, let's make the trend line common to all sectors. So we will uncheck sector label so that there's not a separate trend line for each sector, but rather common trend line. So we see across all sectors, do schools that are higher cost produce graduates that earn more, and it is a positively sloped trend. Of course, here we see the less expensive publics, many of whom do really well with their students. You can put a label on these colleges. Probably not very many labels will show up, but at least we could see Franklin Owen College of Engineering right outside of Boston. They do very well with their graduates, as do all the pharmacy schools. All right, where's Union College? How are we going to find Union College here? Well, we need to create a helper filter or helper set so that we could really pinpoint where Union is. So let's do institution names here, and let's put institution names on filter. We're going to select from the list. Let's uncheck them all, and let's search for Union College, and there it is. Union College. We'll say okay to that. And let's find out where we are. Which one of these unit ID is Union? How about we use a city? This is us. This is us. And so let's create a set. Union College in Schenectady. We'll call it Union. I'll say okay to that. And I'll go back to our scatter plot and put Union on the filter so that we only see Union. Okay, so Union, there's the net price, there's the earnings. Let's annotate Union's mark. Let's just leave it as a Union. We don't need any of these other pieces of information. We just want to know where our data point is. Let's format it so that we can see the line. Let's make it nice and dark. Let's add an arrow. Let's make the big arrow. Yes. And sure, we can leave it at that. Now we can remove the filter. And there we are. There is Union College above the trend line. So our graduates earned more than would be expected given our costs. All right, so that appears that the Union is a pretty good deal. And that is the exam.